Hi everyone, my name is Taojiannan. I'm a PhD student at the University of Central Florida. I'm going to present our work revisiting training-free NAS matrix, an efficient training-based method. Recently, training-free NAS methods leverage theoretical findings in neural networks to rank models without training. Two widely used metrics are the linear regions and neural tangent kernel. However, the most straightforward training-free metric, the number of parameters of a network, is overlooked in previous works. We show that the number of parameters achieve competitive performance with training-free metrics. And we also find that these training-free metrics have a high correlation with the number of parameters. This makes us wonder whether these training-free metrics work similarly as the number of parameters, while being unnecessarily complicated. To validate our question, we split the networks in NAS Bench 201 into 8 groups, and the networks in the same group have the same number of parameters. This prevents the metrics from leveraging the parameter information to rank networks. As shown in the figure, training-free metrics achieve comparable or even worse performance than random search method when the parameter information is not available. Motivated by these findings, we try to propose a metric which provides additional information than parameters in ranking networks. Specifically, we leverage the training dynamics angle metric. Angle metric is defined as the angle of model weights before and after training. In this work, we find that angle metric and the final prediction layer has a no correlation with the number of parameters, but high correlation with model performance. Besides angle metric, we also use the training loss as another metric. Then our final metric is the combination of those two metrics by adding the ranking index. To reduce training cost, we sample a small proxy datasets from the target dataset and only train the model for a few iterations. To evaluate the effectiveness of the proposed metric, we first show the correlation with number of parameters. The table shows that our metric has much lower correlation with number of parameters compared to training-free metrics. Then we show that our method achieves significantly better performance than training-free metrics on networks with the same number of parameters. This demonstrates that our metric provides additional information in ranking networks. We also evaluate our method on existing NAS benchmarks. Our method achieves comparable or better performance than previous NAS methods at much lower search cost. Our search cost is even comparable with the training-free method. We hope our findings could inspire future works to design metrics that provide more parameter-independent information on ranking networks. And our findings also raise the necessity to design new search spaces where number of parameters does not dominate the model performance, to better evaluate the effectiveness of a NAS metric and understand how it works. Thanks for your attention.